Physical properties of condensed phases. For example, the intermolecular bonding, and then here's an example of how this would be expressed for covalent bond between chlorine. The solid line indicates a bond within the molecule, while the dotted line indicates a much weaker bond between molecules. Hydrogen bond in water, H2O, hydrogen bond in ethanol, C2H5OH. Heating curves, Q equals M capital S delta T. So it looks like this has been transformed as you've cut and pasted it from the original, but in the original this should be a triangle, which is the Greek letter delta. So MS delta T, where Q equals heat in joules, capital J, M equals mass in grams, G, and delta T is the change in temperature calculated by final temperature minus initial temperature in degrees Celsius. And I should probably mention here that the change in temperature is the same for Kelvin. Capital S is specific heat capacity for the substance in units of joules per gram degree Celsius. Enthalpy of diffusion, not diffusion, that shouldn't say diffusion. So that says diffusion in the original. You need to go back and change that. It's enthalpy of fusion. Delta H FUS is the heat per mole, kilojoules per mole, required to melt a substance. The enthalpy of vaporization, and I can't remove the silly thing here, so it should say delta H subscript VAP for vaporization, is the heat per mole, kilojoules per mole, required to vaporize a substance. The delta H of vaporization is always larger in magnitude than the delta H of fusion. S of ice, or specific heat capacity of ice, is 1.996 joules per gram degree Celsius. Specific heat capacity, or capital S of water, equals 4.18 joules per gram degree Celsius. Specific heat capacity, or capital S of steam, equals 2.108 joules per gram degree Celsius. Delta H of fusion is equal to 6.06 kilojoules per mole, and delta H of vaporization is equal to 40.7 kilojoules per mole. To determine the number of moles, it is divided by the molar mass of water, 18.02 grams per mole. So 1 times 103 grams divided by 18.02 grams per mole equals 55.49 moles per water. Okay. I'm not sure why that 1 times is there. I'd have to look at the original document. I'm not really sure, but it doesn't change the value at all, but I'm just a little curious why it's there. Okay, from negative 20 degrees Celsius to 0 degrees Celsius, Q equals M S of ice delta T. So that's 1 times 10 to the third grams times 1.996 joules per gram degree Celsius times 0 minus negative 25 degrees Celsius is 4.99 times 10 to the fourth joules is equal to 49.9 kilojoules. From solid to liquid state. Delta H equals delta H of fusion times mole of water equals 6.0 kilojoules per mole of water times 55.49 moles of water equals 332.94 kilojoules. Oh, okay, I know what this is here. This isn't 1 times 103. This is 1 times 10 to the third. I'm looking at a value of 1,000 grams. So that's 1 times 10 to the 3 grams. Okay, so that's what that is. So don't say 1 times 103. That's completely wrong. Couldn't figure out what was going on there. So that's 1 times 10 to the 3 grams. All right. Okay. From 0 degrees to 100 degrees Celsius, Q equals M S of water times delta T equals 1 times 10 to the third grams times 4.18 joules per grams degrees Celsius multiplied by 100 minus 0.0 degrees Celsius equals 4.18 times 10 to the fifth joules equals 418 kilojoules. From liquid to the gas state. Delta H equals delta H of vaporization times mole of water that should be a subscript there, equals 40.7 kilojoules per mole of water times 55.49 moles of water equals 2,248.443 kilojoules. So I would also like, I'm going to highlight this, I would like this to be crossed out in the original document because these units are being canceled out. And that's important for the student to understand how the final units are going to be kilojoules. Because moles of water divided by moles of water, which is what happens here, is 1. Okay, from 100.0 degrees Celsius to 105.0 degrees Celsius, Q equals ms of steam times delta T equals 1 times 10 to the third grams times 2.18 joules per grams degrees Celsius times 105.0 minus 100.0 degrees Celsius equals 4.18 times 10 to the fifth joules equals 10,540 joules equals 10.54 kilojoules. Alright, let's see. Okay. The total energy is the sum, 49.9 kilojoules plus 332.94 kilojoules plus 418 kilojoules plus 2,258.443 kilojoules plus 10.54 kilojoules equals 3,069.823 kilojoules equals 3.1 times 10 to the third kilojoules in correct sig figs. Q equals ms delta T. So the reason that's going to default into a capital D is the delta is the capital D in the Greek language. So, alright, let's look at phase diagrams, and this is the last part of it. Delta H is positive, delta H is negative.